Imagine looking up into the freezing blue sky over Europe in 1944. A low, droning hum rattles the window panes, vibrating through the floorboards of every home from the French coast to the heart of Germany. It is not a thunderstorm. It is the sound of 4,000 Wright cyclone engines dragging thousands of tons of aluminium, high explosives, and human resolve at 25,000 feet. This is the United States Army Air Forces. Specifically, this is the mighty 8th Air Force. You are witnessing 1,000 heavy bombers flying in a single massive formation. It is a three-dimensional phalanx of air power stretching for miles across the horizon, leaving brilliant white contrails against the stratosphere. 10,000 American boys, barely out of high school, suspended in freezing tin cans, flying into the teeth of the most experienced and lethal anti-aircraft defense network the world had ever seen. The Luftwaffe aces are waiting for them. The flak batteries have their firing solutions locked. The verdict of the air war is about to be written in fire and falling metal. If you want to understand how wars are actually won, not in the sanitized versions of Hollywood movies, but in the brutal mathematics of logistics, firepower, industrial attrition, and cold steel, you are in the right place. Subscribe to the channel, hit the notification bell, and join our command staff. We analyze the machinery of war, the tactical blunders of high command, and the unyielding realities of the battlefield. We do not deal in myths, we deal in the hard facts of military history. To comprehend the sheer scale of a 1,000-bomber raid, we have to rewind the clock and understand the strategic foundation that put those planes in the air. This was not a spur-of-the-moment tactic. This was the culmination of a military doctrine decades in the making. Go back to the muddy, blood-soaked trenches of World War I. The world had watched modern armies bleed themselves white for yards of shattered earth. The machine gun and barbed wire had created a static, defensive nightmare. Military thinkers across the globe were desperate for a way to bypass the trench, to strike directly at the enemy's heart. In the United States, a visionary and highly controversial officer named Brigadier General Billy Mitchell believed he had the answer: air power. In 1921, Mitchell proved his point by sinking the captured German battleship Ostfriesland using bombers, much to the fury of the traditional battleship admirals in the United States Navy. Mitchell preached that the next war would be won in the air by destroying the enemy's ability to wage war before their armies even reached the battlefield. He was court-martialed for his insubordination, but his disciples listened. Those disciples gathered at the Air Corps Tactical School at Maxwell Field in Alabama during the 1930s. There they developed what became known as the industrial web theory. This doctrine argued that a modern industrialized nation was like a spider web. It relied on a highly interconnected system of factories, power plants, transportation networks, and raw materials. If you could identify and destroy the critical nodes of that web, the entire war machine would collapse. You did not need to kill every enemy soldier on the front line. You just needed to destroy the factory that made their bullets, the refinery that made their fuel, and the rail yards that delivered their rations. This is not a new concept in American military history. If we look back to the American Civil War, General William Tecumseh Sherman executed the exact same strategic philosophy during his march to the sea. Sherman did not just fight the Confederate Army. He tore up the railroads, burned the cotton gins, and destroyed the agricultural base of Georgia and the Carolinas. He waged total war on the Confederacy's ability to sustain its military forces. Or look at General Ulysses S. Grant during the siege of Vicksburg, strangling the logistical lifeline of the Mississippi River. The Air Corps Tactical School simply took Sherman and Grant's philosophy of logistical strangulation and elevated it 25,000 feet into the sky. They believed that heavily armed multi-engine bombers, flying in tight formations at high altitudes, could fight their way to any target, drop their bombs with pinpoint precision, and return home. The bomber, they claimed, would always get through. But how do you execute a strategy based on pinpoint accuracy when your bombardier is breathing through a rubber hose at -60 degrees Fahrenheit, being shot at by radar-guided artillery, while enemy fighter planes dive at him at 400 miles per hour? You build a flying fortress. The United States entered the Second World War with two primary heavy bombers that would carry the weight of the strategic bombing campaign in Europe. The first and most famous was the Boeing B-17 Flying Fortress. The B-17 was a masterpiece of aeronautical engineering for its time. Let us look at the definitive wartime model, the B-17G. It was 74 feet long, with a massive 104-foot wingspan, designed to provide lift in the thin air of the upper atmosphere. It was powered by 4 Wright R1820-97 Cyclone radial engines. Each of these 9-cylinder power plants generated 1,200 horsepower, equipped with General Electric turbo superchargers to maintain manifold pressure at high altitudes. The B-17 was rugged. It could have its tail section shredded by cannon fire, 2 engines shot out, hydraulic lines severed, and still manage to limp back across the English Channel. But its most defining feature was its armament. The B-17G bristled with 13 Browning M2 50 caliber machine guns. These were not light infantry weapons. The AN/M2 aircraft gun fired a half-inch diameter armor-piercing incendiary tracer round at a cyclic rate of 800 rounds per minute. The bomber had a chin turret to defend against head-on attacks, a top turret, a belly-mounted Sperry ball turret where a gunner curled into a fetal position suspended in the freezing slipstream, waist guns, and a tail stinger. The second heavy hitter was the consolidated B-24 Liberator. The B-24 was a slab-sided, ugly workhorse compared to the graceful lines of the Flying Fortress. It utilized a highly efficient Davis airfoil wing design, which gave it a higher top speed, a longer range, and a heavier bomb load than the B-17. While a B-17 might carry 4,000 to 5,000 pounds of bombs to a target deep in Germany, the B-24 could carry up to 8,000 pounds over a similar distance. However, the B-24 had a glass jaw. It was notoriously difficult to fly in tight formations, required heavy physical exertion on the control yoke, and was far less capable of surviving severe battle damage. If a B-24 was forced to ditch in the ocean, its high-mounted wing and weak lower fuselage meant the aircraft often broke in half upon hitting the water, trapping the crew inside. To deliver the ordnance, both bombers relied on the Norden Bombsight. This was one of the most closely guarded secrets of the American military, an analog mechanical computer packed with gyroscopes, gears, and electric motors. The bombardier would input the aircraft's airspeed, altitude, and wind drift. The bombsight would calculate the exact trajectory and, at the critical moment, actually take control of the aircraft's autopilot to fly the plane during the final bomb run. The marketing propaganda claimed the Norden Bombsight could drop a bomb into a pickle barrel from 20,000 feet. In a vacuum, over a peaceful desert testing ground in Nevada, perhaps it could. But over the industrial Ruhr Valley in Germany, dealing with a 120-mile-per-hour jet stream, blinding cloud cover, and the violent concussions of flak bursting all around the aircraft, that pickle barrel became a scatter zone 3 miles wide. Precision daylight bombing was the doctrine, but area bombardment became the grim reality. Against this American armada stood the German Luftwaffe, specifically the Jagdwaffe, the fighter force tasked with the defense of the Reich. The Luftwaffe was built under the command of Hermann Göring, a politically powerful but strategically incompetent leader who spent more time looting art and nursing a morphine addiction than managing his air force. Before the war, the Luftwaffe had actually experimented with a 4-engine heavy bomber, the Ural bomber program, championed by General Walter Wever. But when Wever died in a plane crash in 1936, the strategic bomber program died with him. The German High Command, obsessed with the concept of blitzkrieg, chose to build a tactical air force. They built dive bombers like the Stuka and medium bombers like the Heinkel He-111 to act as flying artillery, supporting the panzer divisions on the ground. They did not build a strategic air force capable of fighting a long-range industrial war. How do you defend a continent with a tactical air force? The short answer is, you struggle. When the American heavy bombers began appearing in the skies over Europe, the Luftwaffe realized their standard interceptors were not designed to take down 4-engine behemoths. The backbone of the German fighter force consisted of the Messerschmitt Bf 109 and the Focke-Wulf Fw 190. Let us analyze the Focke-Wulf Fw 190A8, the premier bomber killer of the German arsenal. It was powered by a massive BMW 801 14-cylinder radial engine, producing over 1,700 horsepower. The Fw 190 was heavily armored and brutally armed. Standard armament included 2 13mm machine guns and 4 20mm MG151 cannons. But 20mm shells often lacked the kinetic energy to bring down a B-17 quickly. The bomber would absorb the hits and keep flying. So, the Germans upgraded. They installed the Mk108 30mm cannon. This weapon fired a massive high-explosive mine shell known as the Minengeschoss. The shell had thin walls and was packed with explosive filler. When it hit the aluminum skin of a bomber, it detonated with devastating force, blowing massive holes in the airframe. Tests showed that a single 30mm hit could tear the wing off a B-17 or B-24. 3 hits anywhere on the airframe guaranteed a kill. But there was a catch. The Mk108 cannon had a very low muzzle velocity. It fired its massive shells at just over 1,600 feet per second. In aerial combat terms, it was like lobbing a grapefruit. To hit a moving bomber, the German pilot had to get dangerously close, closing the distance to less than 400 yards. Would you willingly fly a lightly armored, single-engine fighter into a formation of 1,000 bombers, each bristling with 13 heavy machine guns? When a German pilot approached a combat box of B-17s, he was not facing one gunner. He was facing a mathematically designed crossfire. The American combat box formation was a 3-dimensional porcupine. Squadrons were staggered at different altitudes, overlapping their fields of fire. A single German fighter diving on the formation could be tracked by 50 to 150 caliber machine guns simultaneously. The sky was filled with a lethal web of armor-piercing incendiary tracer rounds. To survive, the Luftwaffe developed the Sturmbocker, or battering ram tactics. They bolted heavy steel armor plates to the sides of their FW-190s, installed bullet-resistant glass on the canopy, and ordered their pilots to attack from the rear, flying straight through the American defensive fire until they were close enough to guarantee hits with their 30mm cannons. It was a brutal, high-attrition tactic born of absolute desperation. We must also compare the industrial engines driving these two forces, because this was a war of production as much as a war of combat. The United States had transformed into the arsenal of democracy. Look at the Ford Motor Company's Willow Run plant in Michigan. Charles Sorensen, Ford's production genius, designed a factory with an assembly line over a mile long. They applied automotive mass production techniques to aircraft manufacturing. At its peak, Willow Run was rolling a brand new, fully equipped B-24 Liberator off the assembly line every 63 minutes. Over 8,600 bombers came from that single factory alone. The United States was producing aircraft, trained crews, aviation fuel, and bombs at a rate that defied human comprehension. Germany, on the other hand, did not fully mobilize its economy for total war until 1943, under the direction of Minister of Armaments Albert Speer. Speer performed administrative miracles, decentralizing German aircraft production, moving factories into caves, mines, and dense forests to hide them from the Allied bombers. He utilized millions of slave laborers from conquered territories to maintain production lines. German machine tools were exceptional, and their engineering was brilliant, but their supply chains were incredibly brittle. You can manufacture 3,000 Focke-Wulf fighter planes a month, but if you do not have high-octane aviation fuel, because the 8th Air Force just leveled the synthetic oil plants at Leuna and Politz, you do not have an Air Force. You just have a collection of very expensive lawn ornaments. The American strategy was designed to break those specific industrial bottlenecks. The men commanding this American juggernaut had to learn their lessons in blood. Initially, the 8th Air Force was commanded by General Ira Eaker. Eaker was a staunch believer in the pre-war doctrine that heavily armed bombers, flying in tight formations, could defend themselves without fighter escort. He believed the combat box was impenetrable. He was wrong. In the summer and fall of 1943, during the deep penetration raids against the ball bearing factories at Schweinfurt and the aircraft plants at Regensburg, the 8th Air Force suffered catastrophic, unsustainable losses. On the second Schweinfurt raid, known as Black Thursday, the Americans sent 291 B-17 into Germany. 60 were shot down. 17 more were damaged beyond repair. Over 600 airmen were killed or captured in a single afternoon. You cannot win a war of attrition when you are losing 20% of your attacking force on every mission. The math simply does not work. Think of the Spanish Armada in 1588. A massive, supposedly invincible fleet of heavy galleons sailing into hostile waters, relying on tight formation and heavy guns for defense. The English defeated them not by matching their size, but by using smaller, faster, highly maneuverable ships and fireships to break the Spanish formation, single out the stragglers, and destroy them piecemeal. The Luftwaffe did the exact same thing to the American bomber boxes. They used twin-engine fighters, launching unguided rockets from outside machine gun range to blast the formations apart. Once a bomber was damaged and fell out of the protective crossfire of the box, the single-engine fighters would swarm it like sharks smelling blood in the water. The crisis forced a change in command and a radical shift in doctrine. General Karl Spaatz took over the Strategic Air Forces, and General Jimmy Doolittle, the hero of the 1942 Tokyo raid, took command of the 8th Air Force. Doolittle made a decision that changed the course of the air war. He took the leash off the American fighter pilots. Previously, American escort fighters were ordered to stay close to the bombers, flying a defensive screen. Doolittle ordered his fighters, particularly the newly arrived P-51 Mustangs, equipped with drop tanks that allowed them to fly all the way to Berlin and back, to go hunting. Their primary objective was no longer just to protect the bombers. Their objective was to seek out and destroy the Luftwaffe wherever it could be found, in the air or on the ground. But even with fighter escort, the environment itself was trying to kill the bomber crews. The air war over Europe was fought in a realm utterly hostile to human biology. At 25,000 feet, the ambient temperature drops to -60 degrees Fahrenheit. The air is so thin it cannot sustain consciousness. The B-17s and B-24s were unpressurized. The crews had to wear heavy sheepskin flying jackets, thick gloves, and electrically heated blue suits that plugged into the aircraft's power grid. If the heating coils in your suit short-circuited, they could burn your skin to the bone. If the power failed, you would suffer severe frostbite within minutes. Gunners had to manually clear jams in their machine guns with bare hands, leaving skin frozen to the freezing steel of the receiver. The crews breathed pure oxygen through rubber masks. If the moisture from a crewman's breath froze inside the mask and blocked the airflow, he would pass out from hypoxia in seconds and die silently in his seat, unnoticed by his crewmates who were busy fighting off German interceptors. Engines threw connecting rods, superchargers caught fire, and the sheer physical exhaustion of flying a heavy, vibrating, freezing machine through hostile skies for 8 hours took a massive psychological toll. And then there was the flak. The German Fliegerabwehrkanone, specifically the infamous 88mm anti-aircraft gun. Flak was not just soldiers aiming rifles at the sky. It was a sophisticated, mathematically driven system of destruction. German radar arrays, like the Würzburg Ries, would track the incoming bomber streams, calculating altitude, speed, and heading. This data was fed into mechanical predictors, which calculated the exact fuse setting required for the 88mm shell to detonate at the precise altitude of the bombers. The Germans did not aim at individual planes. They fired box barrages, filling a specific grid of airspace with thousands of exploding shells. When an 88mm shell detonated, it sent hundreds of jagged, razor-sharp shards of steel shrapnel tearing through the sky. A direct hit was not necessary to bring down a bomber. A near miss would punch hundreds of holes in the thin aluminium skin of the aircraft, severing hydraulic lines, smashing oxygen bottles, igniting fuel tanks, and tearing through human flesh. The sky over a German target would turn black with the smoke of thousands of explosions, a terrifying cloud of death that the bomber crews simply had to fly straight through, unable to take evasive action during the final bomb run. The stage is set. It is 0200 hours at a dozen airbases scattered across the foggy countryside of East Anglia in England. Inside the Nissen huts, the briefing rooms smell of stale coffee, cigarette smoke, and nervous sweat. The base commander pulls back the curtain on the wall map, revealing a red ribbon of yarn stretching from the English coast across the North Sea, deep into the heart of the Third Reich. The target is Berlin. The industrial web is about to be struck. Out on the freezing tarmac, ground crews are loading thousands of 500-pound general-purpose bombs into the bays and belting miles of 50-caliber ammunition. The radial engines begin to cough, spit fire, and roar to life, shattering the pre-dawn silence. The massive armada begins the complex, dangerous process of forming up in the dark, climbing through the thick cloud cover to assemble into their combat boxes over the English Channel. Across the water, on the coast of occupied Europe, the massive antennas of the German Freya early warning radar systems are already rotating. The operators watch the glowing green screens as a massive solid blip appears, moving steadily eastward. The alarms sound in the Luftwaffe fighter sector headquarters. The orders go out to the Jagdgeschwader. The pilots sprint to their Focke-Wulfs and Messerschmitts. The air raid sirens begin their mournful wail across the cities of Germany. The unstoppable industrial machine of the United States is hurtling toward a head-on collision with the desperate, fanatical defense of the Luftwaffe, and the sky is about to catch fire. The moment those massive formations crossed the Dutch coast, the element of surprise evaporated into the freezing air. The German air defense network, the Kammhuber line, was already tracking their telemetry. Giant Freya early warning radar dishes rotating on the coastline picked up the bomber streams while they were still assembling over the English Channel. By the time the B-17s and B-24s reached the continent, Würzburg-Rees targeting radars were feeding precise altitude and heading data to the anti-aircraft batteries and fighter command centers. The Luftwaffe controllers sitting in darkened bunkers knew exactly where the Americans were going, how high they were flying, and how many aircraft were in the formation. The hunters were being vectored into position. To survive this gauntlet, the bombers relied on their fighter escort, and analyzing this escort reveals a critical evolution in American military engineering. In the early stages of the daylight bombing campaign, the primary escort was the Republic P-47 Thunderbolt. The P-47 was a flying tank. It weighed over 15,000 pounds fully loaded, making it the heaviest single-engine fighter of the war. It was powered by a massive Pratt & Whitney R2800 double Wasp 18-cylinder radial engine, generating over 2,000 horsepower. It packed 8 50-caliber machine guns in the wings, creating a buzzsaw of firepower that could shred a German fighter in a single burst. The Thunderbolt was incredibly rugged, capable of diving at over 500 miles per hour and absorbing tremendous battle damage. But it had a fatal flaw for strategic bombing. It was thirsty. Even with external drop tanks, the P-47 simply did not have the fuel capacity to escort the bombers all the way to targets deep inside Germany, like Berlin or Leipzig. They would reach their maximum operational radius, a boundary the bomber crews grimly called the doghouse line, and they would have to turn back. When the Thunderbolts banked away, the Luftwaffe was waiting. The German fighters would loiter just outside the P-47's maximum range, watching the escorts turn for home, and then they would slaughter the unprotected bombers. How do you project fighter power across a continent when your best aircraft cannot carry enough fuel? You build a hybrid masterpiece. Enter the North American P-51 Mustang. The Mustang changed the entire arithmetic of the air war. The genius of the P-51 was a combination of aerodynamics and horsepower. It utilized a revolutionary laminar flow wing design, which drastically reduced aerodynamic drag, allowing the aircraft to slice through the air with far less friction than traditional designs. But the real magic happened when American engineers took the original Allison engine out and bolted in a Rolls-Royce Merlin engine built under license in the United States by the Packard Motor Car Company. The Packard V16507 Merlin was a liquid-cooled, supercharged V12 engine that gave the Mustang exceptional high-altitude performance. To solve the range issue, the Americans did something incredibly simple, but logistically brilliant. They equipped the Mustangs with disposable external drop tanks. Many of these tanks were not even made of aluminum, which was a critical war material. They were made of compressed, resin-impregnated paper. A P-51B or D model could carry two 108-gallon paper drop tanks, fly all the way to Berlin, drop the empty tanks when the Luftwaffe attacked, and fight on internal fuel with the agility of a lightweight interceptor. This technological leap allowed General Jimmy Doolittle to implement a radical tactical shift. We can compare this shift directly to the evolution of cavalry tactics during the American Civil War. In the early years of the Civil War, Union cavalry was often used passively, tied down to guarding infantry lines and supply wagons, much like the early bomber escorts were tethered to the combat boxes. But in 1864, Union General Philip Sheridan took command of the cavalry in the Shenandoah Valley. Sheridan unchained his horsemen. He sent them on aggressive, independent hunter-killer sweeps to seek out and destroy the Confederate cavalry of J.E.B. Stuart before they could even threaten the Union infantry. Doolittle did the exact same thing in the stratosphere. He ordered his Mustang pilots to stop flying close formation with the bombers. He sent them out ahead of the bomber streams on massive fighter sweeps, hunting the Luftwaffe on their own terms, strafing German airfields, and destroying the interceptors as they were trying to climb and assemble. But the sky is a vast three-dimensional ocean, and no fighter screen is impenetrable. The Luftwaffe adapted to the American combat box by deploying their Zerstörergeschwader, the heavy destroyer squadrons. These units flew twin-engine fighters like the Messerschmitt Bf 110 and the Me 410 Hornisse. These aircraft were too sluggish to dogfight with a Mustang or a Thunderbolt, but they were heavily armed and deadly against bombers. The Germans equipped these heavy fighters with the Werfer Granate 21. This was a 210mm unguided rocket, originally designed as an infantry mortar, fired from tubular launchers strapped under the wings of the fighters. Why would the Luftwaffe use highly inaccurate, unguided rockets against fast-moving aircraft? Because they were not trying to hit a specific plane. They were trying to break the structural integrity of the combat box. The German heavy fighters would hover 1,000 yards away, well outside the effective range of the bombers' 50-caliber machine guns. They would ripple-fire these massive rockets into the center of the American formation. The rockets had time fuses set to detonate at a specific distance. When a 210mm warhead exploded in the middle of a bomber formation, the concussive shockwave and the massive shrapnel cloud were devastating. The goal was to blast the tight formation apart, forcing individual B-17 and B-24 to scatter and break their interlocking fields of defensive fire. Once the formation was broken, the single-engine Focke-Wulf Fw-190s and Messerschmitt Bf 109s would execute the most terrifying maneuver of the air war, the head-on pass. This tactic was perfected by German aces like Egon Meyer. The German pilots realized that attacking a bomber from the rear meant flying through a gauntlet of tail and waist gunners. But attacking from 12 o'clock high exploited a critical weakness. Early model B-17s and B-24s had very limited forward-facing firepower, and the frontal armor protecting the cockpit was weak. Let us analyze the brutal geometry of a head-on attack. A B-17 is flying eastward at 250 miles per hour. A Focke-Wulf 190 is diving from the west at 350 miles per hour. The closure rate is 600 miles per hour. That is nearly 900 feet per second. The German pilot has exactly 2 to 3 seconds to aim, fire his 30mm cannons, and violently push his stick forward to dive under the bomber to avoid a mid-air collision. For the American pilots and bombardiers sitting in the glass nose of the bomber, it was a game of aerial chicken against an enemy firing high-explosive shells directly at their faces. The Americans countered this by introducing the B-17G, which featured a powered chin turret armed with twin 50-caliber machine guns specifically designed to break up these frontal assaults, forcing the German fighters to fly through a wall of lead before they could get into firing range. As the bomber stream fought its way through the interceptors, they approached the most critical phase of the mission, the initial point, or IP. This was a predetermined geographical landmark where the bomber formation would make its final turn toward the target. From the IP to the target, evasive action was strictly forbidden. The bombers had to fly straight, level, and at a constant speed, regardless of what the enemy threw at them. This straight and level run was necessary for the bombardier to use the Norden Bombsight accurately. This final run was known as Flak Alley. The German anti-aircraft artillery, the flak artillery, was waiting. The backbone of this defense was the 88mm Flak 36. This weapon fired a 23-pound high-explosive shell to an altitude of over 30,000 feet. When the shell detonated, it shattered into roughly 1,500 jagged, red-hot steel fragments, expanding outward at supersonic speeds. The German radar-guided fire control systems would calculate a box barrage. They would not aim at the lead bomber. They would calculate a three-dimensional grid of airspace directly in the bomber's flight path and fill that grid with hundreds of exploding shells. The physical reality of flying through a flak barrage is difficult to comprehend. The sky turned black with greasy smoke. The concussions from the exploding 88mm shells violently tossed the 30-ton bombers around like toys in a hurricane. Shrapnel tore through the unarmored aluminium skin of the aircraft with the sound of tearing canvas. It shattered plexiglass, severed hydraulic fluid lines that sprayed highly flammable liquid across the freezing cabin, and tore through the bodies of the crew. But the pilot could not turn. He had to hold the yoke steady, fighting the turbulence, while the bombardier took control. In the nose of the lead bomber, the bombardier hunched over the Norden Bombsight. He adjusted the dials, inputting the wind drift and ground speed, watching the crosshairs slowly creep toward the aiming point, perhaps a specific rail yard or a synthetic oil refinery. The bombsight was actually flying the plane through its connection to the autopilot. When the crosshairs intersected, the mechanical computer automatically triggered the release mechanism. The bomb bay doors snapped open, causing a massive increase in aerodynamic drag that the pilot had to instantly counteract. And then the ordnance dropped. A standard heavy bomber load might consist of 10 500-pound M43 general-purpose bombs and hundreds of ANM-50 magnesium incendiary bomblets. As thousands of bombs fell simultaneously from the formation, the aircraft, suddenly relieved of thousands of pounds of weight, would violently lurch upward. Below them, the physics of destruction took over. The high-explosive bombs shattered the roofs and walls of the factories, blowing out the windows and exposing the interiors. Milliseconds later, the incendiaries would crash through the ruined structures, igniting fires that burned at over 3,000 degrees Fahrenheit, turning the industrial web into a raging inferno. The bombs were away, the target was burning, and the formation executed a hard banking turn at the rally point to head for home. But the combat box was rarely intact after the bomb run. Bombers had engines shot out, wings heavily damaged, and crews wounded. A B-17 with only 3 working engines could not maintain the speed and altitude of the main formation. It would slowly fall behind, dropping lower into the freezing sky. This was the straggler, For the Luftwaffe pilots, a straggler was the ultimate prize. The German controllers would vector their remaining fighters toward these crippled bombers. It was a merciless, mechanical execution. The fighters would circle out of range, analyzing the bomber's damage. If the top turret was silent, they would attack from above. If the tail gunner was dead, they would slide in perfectly behind the bomber and pour 30mm shells into the fuselage. The American crew, exhausted, freezing, and often tending to bleeding comrades, had to fight a desperate, losing battle against multiple fresh fighters. If the damage became catastrophic, the bailout order was given, but escaping a spinning, burning, heavy bomber is a nightmare. Centrifugal force would pin crew members to the bulkheads. The narrow catwalks over the open bomb bays were slick with hydraulic fluid and frozen blood. Many airmen were trapped inside as their aircraft tore apart in the sky, spiraling down into the German countryside. The bombs have fallen, the industrial targets are shattered, but the mission is only half over, and the longest, bloodiest stretch of hostile sky still lies between these battered metal fortresses and the safety of the English coast. The flight back across the freezing expanse of the North Sea was a grim, agonizing procession of the maimed and the dying. For the bomber crews who had survived the flak barrages over the target and the gauntlet of Luftwaffe interceptors on the egress, the danger was far from over. The combat boxes were now ragged, loose formations of battered aluminum. Engines were feathered, their propeller blades turned parallel to the wind to reduce drag on dead power plants. Hydraulic fluid and aviation fuel bled from hundreds of shrapnel holes, trailing behind the aircraft like dark ribbons in the icy air. Inside the unpressurized cabins, the temperature remained at 60 degrees below zero, and exhausted crewmen frantically applied tourniquets and administered morphine to their wounded brothers, fighting a desperate battle against blood loss and shock. For the aircraft that were too heavily damaged to maintain altitude, the North Sea became a terrifying, slate-grey graveyard. Ditching a heavy bomber in the ocean was a maneuver of absolute last resort. The B-24 Liberator, with its high-mounted Davis wing and fragile bomb bay doors, was notorious for breaking its back upon hitting the water, often sinking in seconds and taking the trapped crew down with it. The B-17 Flying Fortress fared slightly better, sometimes floating long enough for the crew to deploy their yellow rubber life rafts, provided the radio operator had managed to tap out an SOS with their exact coordinates before the antennas hit the water. But surviving the ditching was only the first hurdle. The water temperature of the North Sea in winter would induce lethal hypothermia in less than 20 minutes. The British Royal Air Force Air-Sea Rescue Service, operating high-speed launches and Supermarine Walrus amphibious aircraft, raced against the clock. But thousands of American airmen simply vanished into the freezing depths, their final resting place unmarked. When the surviving bombers finally crossed the white cliffs of Dover, the relief was palpable. But the grim accounting was just beginning. As the aircraft approached their home airfields in East Anglia, the tower operators watched the sky with a sickening sense of dread. They were looking for the red flares. A bomber firing a red flare from its very pistol on final approach meant there were dead or critically wounded men aboard, signalling the ground ambulances to race onto the tarmac alongside the landing aircraft. The planes touched down, their tires screeching on the concrete, many lacking brakes due to severed hydraulic lines, forcing pilots to ground loop the massive machines into the grass to avoid crashing into the tree lines. As the props spun to a halt, the silence that fell over the air bases was deafening. The ground crews counted the empty hardstands. If a squadron had sent up 12 aircraft that morning and only 7 returned, The brutal mathematics of the air war were written in the empty concrete spaces. The surviving crews piled out of the hatches, their faces blackened with cordite smoke, their eyes hollow with the 1,000-yard stare of men who had just spent 8 hours in a meat grinder. They were handed a shot of rye whiskey at the debriefing hut, interrogated about bomb strikes and enemy fighter tactics, and then sent to their bunks to try to sleep before the entire terrifying cycle repeated the next morning. How do you sustain a military campaign when you are losing 50 to 60 heavy bombers and 600 men in a single afternoon? You rely on a logistical and industrial machine so massive and relentless that it simply overwhelms the enemy's capacity to destroy it. To understand the true scale of this victory, we must look beyond the cockpits and examine the multi-dimensional reality of the air war, starting with the unsung heroes of the tarmac. The ground crews of the 8th Air Force performed miracles of mechanical resurrection on a daily basis. Working in the freezing, driving English rain, often without hangars, these mechanics would take a B-17 that looked like Swiss cheese, patch the aluminum skin with sheet metal and rivets, splice severed electrical cables, and swap out a shattered 1,200 horsepower Wright Cyclone engine overnight. This required an ocean of spare parts, which required a transatlantic shipping pipeline that defies modern comprehension. We can directly compare this logistical triumph to the Battle of the Atlantic. In the early years of the war, German U-boats were sinking Allied merchant shipping faster than the ships could be built, threatening to starve Britain into submission. The United States solved this not just with naval escorts, but with brute force industrial output, building Liberty ships in massive prefabricated sections faster than Admiral Dernitz's torpedoes could sink them. The strategic bombing campaign operated on the exact same principle of industrial attrition. The United States was manufacturing bombers, training pilots, and shipping millions of gallons of 100-octane aviation fuel across the Atlantic at a rate that the German war economy simply could not match. Every bomb dropped on Berlin required a massive logistical tail, stretching all the way back to the oil refineries of Texas and the munitions plants of Ohio. But brute force without intelligence is just blind swinging. The American strategic bombing campaign was guided by one of the most closely guarded secrets of the war, the ultra-intercepts. Deep in the English countryside at Bletchley Park, Allied codebreakers had cracked the German Enigma cipher machine. This gave the Allied High Command unprecedented access to the internal communications of the Luftwaffe and the German state railway, the Reichsbahn. This intelligence was a game-changer. When the 8th Air Force shifted its primary targets from aircraft factories to the German synthetic oil industry in 1944, a strategy heavily pushed by General Karl Spaatz, they didn't just guess if it was working, they knew. Through ultra-intercepts, Allied intelligence read the frantic messages from German field commanders begging for fuel. They read the reports that Luftwaffe fighter squadrons were being grounded, not because they lacked airplanes, but because they did not have a single drop of aviation gas to put in the tanks. This brings us to a critical economic and political paradox of the air war. By late 1944, under the ruthless administrative direction of Albert Speer, German aircraft production actually reached its highest levels of the entire war. Despite the reign of high explosives, the Germans manufactured over 3,000 fighter planes in September 1944 alone by moving their assembly lines into underground caves and railway tunnels. If you only looked at the production spreadsheets, you might conclude that the American bombing campaign was a failure. But how effective is a brand new state-of-the-art Focke-Wulf 190 if it cannot reach the battlefield? The answer is zero. The American bombers had systematically dismantled the German transportation web. They obliterated the marshalling yards, dropped the bridges into the rivers, and shattered the rail network. Speer could build 3,000 fighters, but he could not transport them to the airfields. Furthermore, the destruction of the synthetic oil plants at Leuna and Pollitz meant that even if a fighter reached an airfield, it had no fuel. This forced the Luftwaffe into a death spiral. Because they had no fuel, they could not adequately train new pilots. A replacement German fighter pilot in 1944 was being sent into combat against veteran American Mustang pilots with perhaps 20 hours of total flight time. They were not being sent to fight. They were being sent to die. This tactical reality highlights the most brutal yet effective strategic lesson of the air war over Europe. The original doctrine of the industrial web theory, the idea that you could win the war solely by bombing factories without engaging the enemy military, was fundamentally flawed. Factories can be rebuilt, dispersed, or moved underground. The true victory of the 8th Air Force was not just the destruction of brick and mortar, it was the absolute annihilation of the Luftwaffe as a fighting force. We must compare this to the strategy of Union General Ulysses S. Grant during the Overland Campaign of the American Civil War in 1864. Grant understood that capturing the Confederate capital of Richmond was secondary. The primary objective was the destruction of General Robert E. Lee's Army of Northern Virginia. Grant engaged Lee in a relentless, bloody war of attrition at the Wilderness, Spotsylvania, and Cold Harbor. Grant knew he would take horrific casualties, but he also knew the industrialized North could replace its losses, while the blockaded South could not. General Jimmy Doolittle and General Hap Arnold applied Grant's exact philosophy to the skies over Germany. When Doolittle unleashed the P-51 Mustangs to hunt the Luftwaffe, he turned the bomber streams into bait. The heavy bombers forced the German fighters to come up and defend their cities. When they came up, the Mustangs slaughtered them. The 8th Air Force traded bombers and crews to bleed the Luftwaffe's pilot roster dry. By the time the Allies invaded Normandy on D-Day, the Luftwaffe was effectively castrated. The skies belonged to the Allies, and that air supremacy was bought and paid for with the blood of tens of thousands of American bomber crews. Contrast this total war mindset with a more modern conflict, such as the American air campaign over Vietnam during Operation Rolling Thunder. In Vietnam, the political leadership in Washington heavily micromanaged the bombing campaign. They established restricted zones around Hanoi and Haiphong, forbidding strikes on critical air bases and surface-to-air missile sites for fear of escalating the conflict with the Soviet Union or China. They tried to use air power as a precise diplomatic signaling tool rather than a blunt instrument of destruction. The result was a protracted, agonizing campaign that allowed the North Vietnamese to build the most heavily defended airspace in the world, resulting in massive American aircraft losses, without achieving strategic paralysis. In World War II, there were no restricted zones for the 8th Air Force. The strategy was absolute, unrestricted, industrial warfare. The goal was to break the back of the German war machine by any means necessary. And they succeeded, precisely because the military commanders were allowed to wage war with ruthless, unchained aggression. The verdict of the air war is written in the shattered concrete of the Ruhr Valley and the thousands of white crosses at the American cemetery in Cambridge. The United States Army Air Forces proved that strategic bombing could fatally cripple a modern industrialized nation. But they also proved that the cost in human life would be staggering. The 8th Air Force suffered over 26,000 men killed in action during the Second World War. To put that into perspective, the 8th Air Force suffered more fatal casualties than the entire United States Marine Corps did in all theaters of the war combined. It was a vicious, freezing, high-altitude meat grinder. But the strategic result is undeniable. When the American and British armies crossed the Rhine and pushed into the heart of Germany, they faced a Wehrmacht that was paralyzed. German panzer divisions could not move during the day without being obliterated by Allied fighter bombers. Their supply lines were non-existent. Their troops were starving for ammunition and fuel. The industrial web had been torn to shreds, and the Luftwaffe, once the terror of Europe, had been hunted to extinction in its own skies. The 1,000 bomber raids did not win the war alone, but they made the ground victory possible. They proved that industrial might, paired with relentless, aggressive tactics and the unbreakable courage of the men flying the machines, could dismantle an empire from 25,000 feet. In the brutal calculus of modern warfare, victory rarely comes from a single, flawless masterstroke. It is forged in the furnace of attrition, where the side that can absorb the most punishment, adapt its tactics, and continuously project overwhelming industrial violence, ultimately dictates the terms of surrender. Now we turn it over to you, the command staff. Based on our analysis of the strategic air war over Europe, which factor do you believe was the most critical in finally breaking the back of the Luftwaffe? A. The introduction of the P-51 Mustang and the shift to aggressive fighter sweeps. B. The strategic targeting of the German synthetic oil industry, starving them of fuel. C. The sheer industrial output of the United States, replacing bomber losses faster than Germany could shoot them down. Lock in your strategic assessment and drop your answer in the comments below. Stay sharp, keep your powder dry, and we will see you on the next deep dive into the machinery of war.